Hi, and welcome to the second of our quarterly webinars facilitated by the ASAP programme team. Webinars are intended to introduce elements of the ASAP research programme, facilitate discussion with interested parties, and allow questions to be posed to the research team during the course of research. ASAP East Africa is a programme funded by the DFID East African Research Hub. The programme brings together UK and East African researchers in air pollution, urban planning, economic geography, public health, social sciences and development studies to provide a framework for improved air quality management in East African cities. We are also pleased to welcome participants from India who will be joining the next 4 webinars as part of the GCRF networking grant. Today we are pleased to have presentations from research partners at the University of Birmingham, the Addis Ababa Institute of Technology and the Indian Institute of Technology, Delhi. The first presentation will be focused on predicting the effects of changes in vehicle characteristics and road infrastructure on air pollution within a city environment and will be delivered by Dr. Andrew Quinn from the University of Birmingham. The second presentation will discuss economic and emissions impacts of changing vehicle types and ages in Kigali, Rwanda, and will be presented by Mahabubul Bari of the Addis Ababa Institute of Technology. The third presentation will be focused on integrated air pollution management in Delhi City, delivered by Professor Mukesh Kar and Dr. Isha Khanna of the Indian Institute of Technology, Delhi. The webinar will be recorded for academic use. At any point during the presentations, feel free to type a question into the chat box. Use the speech bubble at the top centre of the screen. We will collate these during the talks and put a number of these to the presenters. Without further delay, I will pass over to Andrew for our first presentation and his response to further information on air pollution monitoring requests.
So some of the comments that have been made, other people would like to understand a bit more about the technical ways in which we are looking to address some of these problems and the tools that we're hoping to produce as part of the project. And of course, a key part of that is to do with air pollution modeling and predicting the way in which we can change air pollution. So I want to, in this talk a little bit about the models that we will be using and how they will answer some of the key questions that we're looking for. So on this next slide, we see that what we've got is air pollution modeling as work package 4 in this project. And what we need to do is take in details about the current conditions around the city. So that might be things to do with the economics, the traffic and the vehicles that are on the road, the kind of building work that's going on, the kind of industrial processes that are going on in the city. Factor all of those into the pollution model, and out of which will come the pollution levels, the distributions, which will hopefully be verified by the measurements that are made as part of work package 2. However, the other key factor, the reason for doing this is actually for the future, because of course what we want to do is look at policy interventions and how these might play out into future scenarios of what the city looks like and how the city operates, and therefore what the effect that will have on pollution levels. So obviously we want to improve pollution levels, but we also want to improve economic development and support it with as many different policy interventions that are effective as possible. So the way in which we're approaching this is that we need 2 elements. One is the air pollution modeling itself, and the other one is an infrastructure model which helps us to link the pollution that's produced with the economic development itself. So I'm going to talk about each of these separately. So the first one is talking about the dispersion model, as we call it. And that is really answering the question, what is the air pollution across the city, both in terms of the spatial extent and in terms of how it changes over time. So in order to look at this is an extremely complicated problem. And so we see that there are many, many different sources of pollution across the city. So there are transport sources, industrial sources, construction sources, and domestic sources from heating and cooking. So we need to have understanding of all of those sources, where they happen and when they happen during the day, during the season, and during the year. And then, of course, there are external sources as well. So in many cities, the kinds of external sources might be dust that's coming in from desert areas or other regions. And this can be a worldwide phenomenon. And these are blown in on the wind, and these changes the air pollution load within the city. And of course, within the city itself, all of these pollutants can react together with the chemistry, particularly driven by the sun, so the photochemistry of the situation. And then, of course, when there's rainfall, some of these pollutants are then washed out onto the ground. And when the rainfall stops and the roads dry out, we can actually get resuspension of pollutants. So we can have complex, different pathways in which pollution can reach the atmosphere and therefore have impact on people's health. So we need to factor all of these in. And the kind of output that we get from these models, you can see on the screen now. This is obviously a picture of London, and you can see the different levels of pollution modeled in different colors. And what's quite apparent from this is that in these in cities, a lot of the air pollution burden is being generated by the traffic. And there is also input there. If you know where the airports are around London, you can also notice where they are on the map here as well. So we need to bring all these factors together, and we can do that in the dispersion model, but we also need to understand a lot about the meteorological conditions, the external sources outside the city, as well as the temporal and spatial geography of the city. And so some of the challenges that we're going to need to face, some of the answers that we're going to need to come across is what is the scope of the city that we're trying to model, and how do we factor in a lot of the different types of data which have different quantities and qualities into the modeling that we're able to do. And this is where I'm going to move over to the second model, because the model HDM4 allows us to link the infrastructure and particularly the highways pollution levels with the economic models. So it helps us to ask and answer questions like, what if our transport policy changes? What if we upgrade certain types of roads in particular ways? What if we change the way in which we construct the roads? Or what if we have radical ideas about changing the vehicles themselves? And the way in which HDM4 works is that we look at representative areas of roads. So we pick some sample areas, types of roads with different characteristics, and we look at the effects and the different pollution that arises from each of those. And we produce tables which look at the emission parameters from different types of roads in different conditions at different times. And then we apply those emission factors across the entire city that we're modeling. And then we look at how those emission sources then interact and add to the other sources in our dispersion model. And in that way, we build up a complete model of the conditions in the city for a given scenario. That might be what's happening today, but it might also be factoring in the effects of different policies for the future. And in that way, we'll build up models of each of our key cities, and they will share a lot of common factors in terms of the type and approach of the modeling that we use, but we will also have individual models of each city. And this fits into the whole of the ASAP project in a number of ways. First of all, the dispersion model links closely with the observations that are made in Work Package 2, the field data collection, because the first stage that we will be undertaking is to develop the model of what the city looks like today, and then verifying that against the measurements that are made in each of the cities. We'll also be taking in a lot of the data that's coming from Work Packages 1 and 3 about the current policies, the current understanding the current vehicle fleets and different development activities and industrial capacity that is existent in each of the cities, and look at how that is managed and what that adds to the current conditions within each city. And we will be looking then also at the ways in which it is planned for those cities to develop in the near future. And then on top of that, we will seek to look at the further future with a lot of the scenario development out of the later work packages. So asking the questions, what if we were to change the variety of different factors within the model? Which are the most sensitive factors? What are the things that can have the biggest change for the positive in the city?
1 minute remaining.
Thank you very much. And so in that way, we'll be able to link together the economic development and the social development through the industry, through transport, and through a lot of different factors within each city with the air pollution index. And we can then look at the spatial distribution and the temporal distribution. So we can look at different seasons of the year. We can look at different pollution episodes, so particularly the worst case scenarios. And we can also look at the impacts of various policies, both from an economic perspective as well as an air pollution perspective. So I hope that's given everybody an understanding of the type of work that we're aiming to undertake and the type of information that we hope to gather and to be able to provide to everybody on the project. Thank you very much.
Yeah, thanks for that, Andrew. Our next speaker is Dr. Bari from Addis Ababa Institute of Technology, and he'll be talking to us about economic and emissions impacts of changing vehicle types and ages in Kigali, Rwanda.
Over to you, Dr. Bari.
Yeah, thank you. Yeah, now I am going to present the economic and emission impact of changing vehicle type and ages in Kigali, Rwanda. I would like to thank the previous presenter regarding, clarifying some of the modeling aspects of HDM4. But having said that, HDM4 would work if there is no change in demand. But, in our case, with the study we did in Rwanda in 2012 and 13, the policy impact did have an impact on the change of vehicle. That's why HDM4 alone would not be able to model it. In order to overcome this problem, then we have decided to check, demand modeling using a logit model. At first, we divide our, the different vehicle into different segments. For example, brand new vehicle, the vehicle is limit less than 5 years, 5 to 10 years, and so forth. Then, since it has two things here. One is they want to impose a restriction on vehicle age limit so that air quality will improve. But it does have impact economic implication as well, because Rwanda is a developing country. Obviously, if you impose vehicle age restriction, and by the way, about 70% of their vehicles they import every year are more than 15 years old. That means within 15 years, about 70% of the vehicle. That's why any restriction on vehicle age would like to have an impact on overall demand on vehicle in the country. That's why at first we have to see the economic consequence of putting age limit on GDP growth, and then we'll have to also assess if we impose age limit, what will be the benefit. For example, reduction of pollutant. And then we'll have to develop a number of scenarios to check whether it will be economically justified to impose age limit. And if so, what would be the optimum age limit Rwanda can impose in order to control air pollution as well as without affecting the economic progress of the country. Okay, next. Yeah, that's why we need to relate the gross GDP with the number of vehicles. We know that if for every country, the number of vehicle, number of ton carried by vehicle, seat capacity, it does have a direct impact with the economic development. Then prior to undertaking this work, we calibrated one model which relates GDP with number of vehicle, number of ton carried by per capita, seat capacity, etc. Next. And you see that our calibrated model was very good. That means we have been able to successfully predict the relationship between GDP per capita and number of vehicles, number of ton carried in the country, so that we'll be able to determine the economic consequence of age limit in Rwanda, imposing age limit on vehicle on Rwanda. Next. And then after that, we divide the whole vehicle fleet with respect to different age. For example, brand new vehicle being the base scenario, then less than 5-year-old, 5-year to 10-year, 10-year to 15-year, like this. And we collected data from the Rwanda Revenue Authority. Then for different groups, we try to see their behavior of purchasing. That means their choice. And what would happen if the price of certain category of vehicle increases, what would be the impact on overall demand? In order to know this, we use multinomial logit model. And using multinomial logit model, we also determine the elasticity for each group of vehicle, so that any impact on demand and increase of price, we will be able to predict using this model. Okay, next. You see, this is the cross elasticities and direct demand elasticities we developed in order to see the impact of change in vehicle price due to imposition of age limit on importation of vehicle, then what would be the impact on overall demand of vehicle? These two equations you use if using from the multinomial model. And after determining the impact of the vehicle due to increase in cost due to imposition of age limit, then for this emission modeling, we use the relationship of HDM4, as our previous presenter rightly pointed out. And in the HDM4, prediction is done on the basis of mainly two parameters, using vehicle consumption and speed. And in some of the pollutants, they also use vehicle age. We have actually 7 pollutants in HDM4 can predict, and out of these are hydrocarbon, carbon monoxide, nitrous oxide, sulfur dioxide, carbon dioxide, particulate, and lead. Out of the 7, this is one relationship. You see, there is a parameter called life. Life means vehicle service life. That means, according to this mechanical and elastic empirical model, the pollutant does have impact with the age of the vehicle. But out of the 7, only 3 are dependent on the vehicle age, others are not. But you know that due to any policy decision, definitely the number of vehicles will change. That would have an impact on overall emission. That's why, although all the pollutant is not age dependent, but the amount of pollution would definitely depend on the number of vehicles in the road and impact on different policy decision on the demand of different kind of vehicle. Okay. Next. You see, yeah, as I mentioned earlier, that out of the 7 pollutant, 3 are dependent on vehicle age, like hydrocarbon, carbon monoxide, nitrous oxide, but the remaining 4 are not dependent on vehicle age, like sulfur dioxide, carbon dioxide, that is greenhouse gas, particulates, and lead. These 4 pollutants are not dependent on vehicle age. But regardless whether it depends on vehicle age or not, as I explained you earlier, that since that due to the policy action, the demand of the vehicle will change. If we impose any restriction, that means we are also putting a cap on the growth of that kind of category of vehicle. That would have an impact on pollution. After consulting with the decision maker, we developed a number of options. For example, if we set the age limit that the importation of vehicle should be 5 years, what would be its impact? Okay, only 1 minute. Okay, then we developed a number of options in order to determine the impact of vehicle age limit on pollution. The next slide, please. And you see, as I mentioned earlier, in Rwanda, about 70% of the vehicle they import normally within more than 15 years old. That's why imposition of age limit on vehicle import would have a serious implication. And they imported the vehicle mainly from Japan and other European countries. Okay. Since we know the price elasticities and we also know the price differential, using this, we were able to determine the demand of different categories of vehicle depending on the policy action which they are going to undertake. Okay, next.
Dr. Bari, I'm going to ask that you wrap up because you are out of time.
Yeah, okay, I like to wrap up. Then, at first we determine the implication on cost. Then on the basis of the cost, then we also determine that what would be the impact on overall demand of different category of vehicle with respect to age. Then after determining the demand, we also estimated different pollutant level in terms of ton. Then using different secondary studies, we also estimated their cost. And then finally, we provided economic appraisal. That means what would be the overall economic benefit. We found that imposition of age limit would not be economically viable. In fact, the economic negative impact of economy will be much higher than the reduction of benefit due to the reduction of pollutant. Thank you.
Excellent. Thank you. Sorry. Yeah, sorry, I'm sorry myself. The final presentation for this webinar is by Mukesh Kari and Isha Khanna from the Indian Institute of Technology, Delhi, and they're going to be giving us a perspective on integrated air pollution management in Delhi city. Over to you.
Thank you very much. So my presentation will be revolving around the integrated air pollution management in Delhi and the National Capital Region, which is around Delhi city. Next slide, please. Just to give you a knowledge of the Delhi NCR, what Delhi NCR is, the area of Delhi National Capital Territory, which we call it Delhi City, is about 1,500 square kilometers. And around this National Capital Territory, which is Delhi City, that the area of Delhi National Capital Region is about 58,000 square kilometers. So this Delhi NCR is looked after by the Delhi NCR task force on all aspects of transport and the pollution. Now in Delhi, at the moment, the PM 2.5 is a cause of concern, because the National Ambient Air Quality Standard of Delhi if you see that slide, annual average is about 118.3, while 24-hour average in summer and winter about 58 and 276, right, which is exceeding the limit of the ambient air quality standards. So we'll show you the graph later in the slides that what was those limit and how they exceeded. So the problem of this PM 2.5 is due to the health risk because they are the group 1 carcinogen, and 96% of particles retained by lung cells are PM 2.5. So it is causing a lot of problems, including the deaths, which is recently reported by the Lancet Report Commission, where 5 billion deaths are caused by the outdoor and indoor pollution in South Asian countries. So the PM 2.5 is a cause of concern. The environmental risk of PM 2.5 in Delhi, which we are observing, is visibility degradation, especially in summer season when temperature goes more than 40, and a lot of summer winds come from the Thar deserts. And during the winters, we have acid rain, acid deposition, or when the humidity is very high, and the precipitation and the cloud formation may also cause a lot of problems for the PM 2.5 secondary aerosol formation, which may also contribute to the visibility degradation and other chemical effects. Next slide, please. Now, these are the standards of the National Ambient Air Quality Standards of India. The Indian standard 24-hour average of PM10 is 100 microgram per hour, while annual average is 60, and the PM 2.5 is 60. 24-hour average and annual average is about 40. That is our standard, with the WHO guidelines have been given as well. So if you see the last slide, it is our concentration is always exceeding these standards. Next slide, please. Yeah, that's the things that you can see. Now, the source contribution of the Delhi NCR of the PM 2.5, which one of the Indian Institute of Technology, Kanpur, has done this study in 2016. You see that biomass burning is the maximum, source contribution of PM 2.5, having 26%, while the secondary particle formation is 30%. That is also a meteorological phenomena when these particles react with other chemicals in the atmosphere and form the secondary particles. The vehicle is contributing about, say, 25%, and rest is about solid waste burning, soil and dust, road dust, construction materials, and coal and fly ash. That is the winter season. Similarly, you see the pie chart of PM 2.5 summer. There also, the coal and fly ash is about 26%, and soil and road dust 28%. So see, the soil and road dust is forming a major part of PM 2.5 pollution during summer. Next slide, please. Next slide. Now, additional PM sources apart from this pie chart. No, please go back. Go back, please. Yeah. These are the additional particulate matter sources, PM 2.5 and PM10, both included. That is domestic kitchen, the diesel generator set, we call it a DG sets. The very, very, very peculiar source in India, especially for Delhi, is the agricultural residue burning in surrounding rural areas of Punjab and Haryana, which are the two states adjoining the Delhi during the various crop seasons. That is an episode which always happens every year during winters and summer. Then the next is the resuspension of the road dust. There is a major source because of the tropical climate. Most of the road dust are resuspended, and where the pedestrian and other people are exposed to that. Then transport of the dust from surrounding area outside the city, which is an external sources, especially during the summer when the Thar deserts winds, when they come from the western Indian side, a lot of particles are come to enter to the Delhi city. Then another source is the brick kilns. The next slide will tell you showing the brick kilns and the land dumps. We have 3 land dumps around in the city of Delhi, which are becoming a source of methane and other gases due to the natural fires being undertaken in those land dumps. Next slide, please. These are the brick kilns which I have shown you in the red color. These are the brick kilns, and if you see the north direction, the predominant direction of the Delhi is about northwesterly. So see the northwesterly direction, the red dots tell you the number of brick kilns. Overall, approximately more than 1,400 brick kilns are situated around the Delhi National Capital Territory. That is the Delhi city. The violet color, that is tells you the Delhi city, while the red, this yellow line tells you the Delhi NCR. So the brick kilns become a very predominant and dominant source of the air quality of Delhi city in terms of particle emissions. Next slide, please. Now, looking at this background, the challenges which we are facing are the four. That the challenges of the PM 2.5 sources are, some of them are uncontrolled sources, which has to be controlled, like brick kilns. They are small scale industry. They don't have much money, but they have to supply to the construction industry. So they are the uncontrolled sources. Second is the unaccounted sources. For example, road dust. We don't have emission factors developed so far. So we have categorized these type of sources as unaccounted sources. Then the geographic location of Delhi is very peculiar. We have a bowl shape of geography of the Delhi, so that bowl shape makes the, especially in winter season, it makes the pollution to stagnate, and then smog occurs. And then the meteorology, which is a major driver of the pollution sources from the external areas surrounding the Delhi state, from Punjab and Haryana. So these are the challenges to be looked into. So in order to, get these challenges, dealt with, we have an urban air quality management framework, which I have just shown you over here. We start with the monitoring and sampling. We have a very dense network of monitoring and sampling stations maintained by the Central Pollution Control Board, which is a nodal agency of India. And then there is a State Pollution Control Board. We call it the Delhi Pollution Control Committee, which has maintaining, say, about 26 stations. Then there is another program by Ministry of Earth Sciences. We call it as a SUFFER program, which is maintaining, say, about more than 10 or 12 stations. So we have a very dense network of these, state-of-the-art continuous emission monitoring stations. Apart from that, we have some mobile stations maintained by the Central Pollution Control Board. So when we have the data, we go for the chemical characterizations. We have done a lot of chemical characterization in various project form, IIT Delhi and IIT Kanpur, these two IITs, to know that what are the properties of these PM 2.5, so that we can have some fingerprinting from the sources. Then we go for the source apportionment. We use this data. Then we identify and quantify the sources. Then once we identify, then we go for the air quality modeling. We generally use dispersion models or receptor models. And then with the predictions, we try to see what are the management and control, and then go for the implementation of the air quality improvement plan, and then we evaluate those plans. So these the air quality management framework, which we are using with the collaboration of the Central Pollution Control Board. Next slide, please. Even after such a dense network and such a systematic program for air quality management, we have some unanswered questions so far, still today. What is the current share of different sources in air pollution in Delhi city? When I say current share, I mean to say current share from not only from the Delhi city, but also from surrounding states. How much coming from surrounding state, how much is produced from the Delhi city? So this is still unanswered. Second is, what is the contribution of surrounding towns in NCR, and how much they are contributing to the PM pollution? And the third is, which are the interventions that can bring down the levels effectively? So those interventions, some are already formulated, but they are not audited. They are not evaluated. As the first presenter has said, that some policy intervention has to be evaluated to see the effectiveness by developing various scenarios that we have to do for the Delhi NCRs. Next question, please. Next slide, please. Now, Delhi, we have done some case studies. So Dr. Isha Khanna will present one of the case studies over here. So I would invite Isha Khanna to continue this presentation.
Hello. So in this, we recently conducted one case study where we have taken two sites. As you can see in the figure, both sites are located in the south part of Delhi city. But one of them, site A, is located in an institutional area, which has major sources like vehicular, commercial, and residential sources other than the institutional sources that exist. Whereas site B is located on a national highway. So it majorly has, other than the vehicular and combustion sources, it also has an industrial area close by. Both of the samplings were done on a curbside location. Next slide. These are the PM 2.5 concentrations on both the sites. As we can see, the sampling was conducted during summer and winter in day and night time separately. If you see, the winter concentrations are higher in the summer, but if compare the two sites, then site B has way higher concentrations for winter, and especially during the winter night as compared to site A. This is because of all the incoming traffic and majorly the trucks which run on diesel fuel, which emit a large quantity of PM 2.5, and these are allowed to enter Delhi city after 8 or 9 p.m. during the night. and that's why we have such high concentrations from winter at night time. And the dotted line you see is the National Ambient Air Quality Standards of 60 micron per meter cube. As you can see, the concentrations during summer are somewhat closer to the standards, but winters is around 3 to 4 times higher than the standard values. Next slide, please. So we, after seeing this, and as Sir mentioned, the major problems we still have is to know how much is the contribution from Delhi city and how much is from the NCR. So we have been awarded this project recently, in which University of Birmingham, University of Surrey, and National Physical Laboratory are our partners, and it's funded by NERC and MOES, in which we are seeing how much is the contributions from Delhi and how much is the contribution from NCR states. Next slide. This is our first site at which we are sampling, which is the IIT Delhi site, which serves as an urban baseline, and we compare all the concentrations of NCR location to this particular site. It has institutional area, as you can see on the figure given here, vehicular emissions, and also a lot of residential area nearby. Next slide. To be able to compare how much is the additional contribution from NCR or from Delhi, we have taken a background site, which is around 200 kilometers upwind and in the north direction to Delhi city. It's placed in Mulana, which is also a university campus, and it has very less population and not major sources nearby other than agricultural area all around it, which is an open area. So this site will be used as the regional background monitoring station to calculate the background concentrations for PM 2.5. Next slide. These are our NCR sites. So the map you see in the center is the outline for Delhi city, and all the stars represent one of the NCR locations. It's starting from Sonipat, Bahadurgarh. Each of these areas actually have industrial area, like few of the sites like Bahadurgarh and Faridabad have industrial area nearby. Some have agricultural area along with it. All of these sites are actually located in an educational institute for capacity building purposes. We conduct sampling for 1 week per site in each of the seasons for summer, winter, spring, autumn. Also, the sampling form is integrated. We have day-night samples, which is like 12-hour samples for day, 12-hour for night. And other than PM 2.5, both organic and inorganic sample analysis is done. After this point, we'll be conducting receptor modeling to actually apportion how much is the contribution from each of the sources at each of the locations, whether more contribution is from the sources from NCR locations or from the Delhi side. The prominent wind direction in this case is northwest. So we have tried to cover all of the sites around Delhi city. Next slide. These are the two kinds of monitors or sampler we have used. The left one you see is the PM 2.5 sampler, which we use for getting the 12-hour samples. It's by Envirotech Instruments, and this actually runs on WINS impactor-based technology. The one you see on the right side is a portable real-time aerosol spectrometer. It runs for the whole 24-hour duration, and we see what is the real-time concentrations and how do they vary for different sizes of particles like PM10, PM 2.5, and PM1. So the
1 minute.
Next slide, please. Yeah, so I'll take over from Isha. Now, with this background, I'll just take a minute or so. I just listed some priority PM abatement options, and these are categorized in different headings if you see. And the green color tells that we are implementing those measures. The yellow color, tells you partly implementing it or it's not very effective, right? And the red means that we have to implement. So if you see very quickly, preventive measures, we have already implemented graded response action plan. We call it as a GRAP. And GRAP is already on the website of Central Pollution Control Board. And depending upon the air quality index, which is what the level it is exceeding, we implement this GRAP system. Then demand and structural measures, we have different, action plan over here, different responses which we have applied, except the third one, that fourth one, that's greater use of public transportation. That is, we are trying our best, but it is not, serving the purpose. We are not able to make the people to change from cars to either buses or metro. Then cleaner technology, we have done a lot of good works on that. The whole Delhi is running on the compressed natural gas, all commercial vehicles. However, we are trying to implement the electric vehicles and hybrid vehicles, and our target is by 2025, the whole Delhi city at least become the 100% electrification of the vehicles. This is the government target. Next slide, please. The economic measures, all these three are the red. We have not yet so far, able to implement these. While the last one is a green color, we have done quite good work on supporting public transportation development in the large cities. We have developed metro here in Delhi. So it has been about more than 200 kilometers of the metro network has been developed. Our target of the metro network is about more than 435 kilometers, which will be bigger than the London metro. Then the command and the control, as far as this is there, this is a carrot and stick policies, and very difficult to control or command by, but we are trying our best. We have National Green Tribunal and many other things which are trying to see that how it can be maintained, how it can be done. Zoning restrictions for private cars, we tried once, but it failed. So, but other things are, implementing in a very slow manner, except the green ones. Next, please. Now, the end of pipe options, the alternative biomass utilization technology to replace open burning, that is important thing which we have not able to maintain it because of the poor people. Slums are here, so how to motivate them, how to get these biomass burning stopped, that is a challenge for us. While the construction and site management, we have some notification from ministry which are monitored very strictly. And awareness program, I think we are doing a lot of work on the awareness. A lot of NGOs are there, societies are there. They are working with the schools in the public places, and I think we are doing a little bit a good work in this awareness area. Now, the drivers of all these priority PM abatement options are the following, which I have listed. One is the highest court of India is the Supreme Court, who has created this committee, call it as Environmental Protection and Control Authority, which is an independent authority. It is doing a lot of good work in implementing various measures. The second is the high-level task force chaired by the PM office. It is directly looking the Delhi pollution and how to stop, how to combat those pollution, what are the measures to be taken, economics as well as the technical. So high-level task force is recently been created. Then we have National Green Tribunal, a special court on environmental code, we call it. It is all over India. Delhi is one court which is always full of cases, and they are trying to solve those conflicting cases. Then State Pollution Control Boards and the Central Pollution Control Board, they are the nodal agencies working for the abatement of the pollution. That's all. Thank you very much.
Excellent, thank you. It's interesting to get a perspective on what's happening in Delhi City when you can start to establish an air quality policy framework when observations of air quality are established. I think there'll probably be a few questions online, but maybe just to kick us off, I was thinking for the first two presentations, but also the last presentation, there was a lot of discussion on vehicle age and impact of air pollution. But what I'm curious about is, what about accounting for the quality of fuel in vehicle emissions and the policy implications of that? Anyone is welcome to answer if you want to jump in from the presenters.
Can the speakers all speak? Yeah, I'm just enabling my hubble.
So I think from my perspective, the quality of the fuel is very important. And as the quality of fuel changes, we will change the emission factors that are associated with the vehicle. So that would be part of the scenario of how vehicles would improve over time. And so any policies that affected fuel quality would also be factored into that.
Yes, you are absolutely right. You know that there are a number of things we need to consider. If you change the fuel, for example, if we go for electric vehicles, obviously it would have a significant impact in reduction of emission. But on the same time, also we have to be also careful, because even in the third presenter from India, they also have one policy that what would be the economic consequence of policy decision. That is also very important. For example, if you want to ban biomass in Delhi, what would be its impact on the slum dweller? That is also important issue. That's why in Rwanda, for example, if we impose age restriction, everybody knows that that will reduce the emission. But what will be the impact of imposing age limit? that will obviously reduce the number of vehicles in the country, and it would have direct impact on their economic growth. That's why there will be always trade-off between policy action and environmental benefit. We will have to strike a balance between these two. That is the main, lesson we learned from the study from the Rwanda.
Is there enough information on fuel type for the individual countries to put it into not only emission inventories but also future scenarios?
Yeah, you can do that, because you know that even in the relationship for every dispersion model, all the pollutant, it depends on the fuel type. If it is a diesel, then obviously your emission will be higher. If it is octane and petrol, it will be lower. And if it is gas, liquefied gas, it will be even lower. That's why in different countries, for example, in the third presenter, they pointed out in Delhi, they converted most of the car to CNG. That means it would have an impact on emission, of course. But having said that, we'll have to always try to strike a balance in developing countries between policy action we take, which would obviously reduce the pollution, and its economic consequence, because we have to strike a balance between these two.
Absolutely.
Can I chip in? Correct.
Yeah, sure.
Actually, I just want some comments. We have an experience in Delhi regarding the fuel quality and the fuel change. What we have experienced that the compressed natural gas in Delhi was implemented around 1998. And all run from compressed natural gas. We have around more than 10,000 buses here, city buses. We have all taxis, that's 70,000 or 80,000, maybe 100,000 now, all on compressed natural gas. So the effect of technically and mathematically, we have not done any exercise that what is the impact of change of this fuel into the environment. But as far as I know, that the visible pollution is reduced. Certainly, we have reduced the visible pollution because earlier, due to diesel, we have a lot of black smokes. But now the problem has become the nitrogen dioxide. The NO2 concentration of Delhi in ambient air is increasing like anything, which is a pollutant coming from the high temperature burning fuel like CNG. So I think we have to maintain a proper balance that we should not go entirely conversion of commercial buses on CNG or on LNG or any fuel. We have to have a balance, and that can only be known if we have a proper development of scenarios using some simulation exercise, so that such type of accidents of one pollutant becomes less, other pollutant becomes high. So that is our experience.
And I think I would totally support that with the kinds of scenarios that we've been using for city development generally, which is not to try and predict what the future will actually be, but rather to explore a range of possible scenarios and see which decisions play out well in a variety of different futures. And so see both the advantages and the disadvantages of different policies without making assumptions about economic growth or changes in society.
Yeah,
Great, thank you.
Sorry, I have one question with the first presenter from Rwanda.
Go ahead.
Yeah, I just want to ask the second presenter that why you have used the Logit model, because currently the dispersion model just to look at the change of vehicle on the pollution aspects. The change of vehicle means the change of emissions, and we can always estimate the emission through the emission factors. What is the emission? If this is the vehicle, this is the emission. We can use the dispersion model or HDM4.
No. Actually, HDM4 it is not a demand prediction model. Here, demand is fixed. But for example, if you impose restriction on certain kind of vehicle, obviously it would have an impact on overall demand. And HDM4 only can predict, using a mechanistic model, that how much pollutant it will emit on the basis of the number of the vehicle. But economic decision, suppose if we impose a certain group, that would have impact on overall demand. And in order to know that how much will be the effect of increasing price on its demand, we use logit model using the vehicle price data of different kind of vehicle on the basis of their age. That's why we will have to do it outside HDM4 because HDM4 doesn't have this capability.
Demand in terms of emissions, suppose demand is now at the moment A, convert calculate emission. After demand become B, then we can always estimate the emission for demand B. Can't we do it?
No, but at first, because it is these pollution impact and pricing impact is different. For example, if you impose restriction on a certain group of vehicles, say ban all vehicles more than 5 years old, that means you are forcing the buyer to buy expensive vehicle. That would have an impact on overall demand. And HDM4 doesn't have the capability to predict those. In order to overcome this problem, we use separate logit model, taking data from the Rwanda Revenue Authority, all the past data, we categorize different group of vehicles and see their change in behavior and estimate elasticity of demand.
Thank you very much. I understand it. Thank you.
Okay, thank you. I definitely want to address one of the questions that have been posed by one of our listeners, and I want to make sure that I do actually ask it correctly. So please do type in if I have interpreted it incorrectly. But someone has asked for a perspective on how, on whether air pollution can be, rather than just considered a development issue, also be sort of raised in profile as being considered a risk or a disaster issue. And I suppose on the same level as a flood might be considered. I don't know if anyone has a perspective on this to provide.
Can I answer this? Hello?
Go ahead.
Yeah, actually, it's a both. It's a combination because, as I told you, it's a trade-off scenario as we saw in Rwanda. For example, definitely from the pollution point of view, the newer the vehicle, the less will be the pollution. Everybody knows that. But Rwanda is a developing country. If we impose too much restriction, obviously, then growth of the vehicle will be reduced. Consequently, it would have an impact on growth, economic growth. That's why we should not also lower the economic growth. We'll have to strike a balance. That's why there is no hard and fast solution for that. We'll have to develop a number of alternative scenarios. Then after analyzing all those, we'll have to develop a compromise solution. We'll be able to reduce the pollution at the same time without hampering the growth or development to a large extent. That's why we'll have to analyze, collect data, and then take a proper decision.
And of course, there is both a long-term development issue and, you rightly say, a short-term impact on very high pollution episodes. And therefore, some of the scenarios that we can explore are around those particular combinations of meteorological conditions and traffic conditions which give rise to these very high pollution episodes, which cause particular problems in mortality and morbidity.
Are there any other perspectives on this? If not, I'm curious whether there are any more questions you'd like to pose for the speakers. Oh, I see we have another one. How do the differing import restrictions in different East African countries affect the situation in individual countries.
Hello?
I assume
Is it for me?
Yeah.
Okay.
You know, in East African communities, their economy are more or less in the same stage, and also they are more or less in the similar stage of development. Definitely, any policy action on reduction of pollutant would have economic consequence. That's why we'll have to collect data, analyze it, and then we'll have to develop a solution which will be, strike a balance between the development needs as well as the requirement of reduction of pollution. That's why there is no hard and fast solution. You will have to analyze the existing situation and find out what would be the most optimum solution for a particular country.
Thank you. If there are no more questions, I suppose just to keep on time, we can wrap up at this point. I'd just like to thank all of the speakers as well, and also to our listeners for participating and providing questions. And just to remind you that the next quarterly webinar will take place in early June, and the newsletter will be circulated in late May to advertise this. And so if you want to get any more information on this, you're encouraged to consult the website or contact the ASAP mailbox. And both are detailed on the top of the reading pack. I just want to check in if there are any more announcements or comments from anyone else. If not, until the next webinar, have a lovely afternoon for the UK and evening for everyone else.